Today's talk will be given by one of our outstanding junior faculty member, Dr. Xiao. Dr. Xiao, all right? And the title of his cutting-edge talk is User Privacy in Mobile Networks, Robocalls, Tracking, and Emerging Solutions. Okay, I have an abstract here, but I don't think I need to read those abstracts for you. Okay? But the title tells you how how interesting and how important this talk is. So let's welcome today's speaker, Dr. Xiao.
All right, thank you, Dr. Chung, for the nice introduction. So today's talk, as you can see from the title, it sounds a little bit like a gaslighting, like what I'm doing is very important. So, but actually, I always believe so. But different people may have different opinions, but I'm offering my opinion and our project addressing these two most important challenges, robocalls and tracking in 5G world. So the agenda of today's talk is I will give you like a brief introduction, why the problems are there and what have been the consequences, follow up by our two solutions for each. So basically how to address robocall scams and how to address the mobile tracking problems. They are focusing on different adversaries and different attacker assumptions. All right. So the first risk, as you can see, I just copied all the text or definitions from the FCC. FCC is the Federal Communications Committee, so they are the regulators for our everyday consumer-grade communications. So anything that are unsolicited or auto-dialed or pre-recorded texts or calls, they are considered as robocalls or robotexts. So whenever you pick up your phone and there's some machine voice or robot voice and it's pre-recorded, you can consider that as a robocall. But what is interesting is not all robocalls are malicious or bad. So normally you will receive like appointment reminders, right? And sometimes you have your calendar reminders or any kind of normal robocalls. I think that they are acceptable. But what is really intriguing or really challenging for the society is the spoofing or imposter scams or the robocall scams. So whenever you see a valid caller ID or number checked, but when you pick up the phone, it seems that they are coming from somebody bad, somebody that is imposing someone else, and that is known as the robocall scam or spoofing scam. So according to FCC, robocall scam, they have to be robocalls and they have to be spoofing somebody else, and also they are selling or promoting illegal or unwanted content. So these are just FCC's definitions. If you see the figures, I use the figures from 2022 by Truecaller, one of the most important commercial players in this user end call blocking businesses. So basically, the number of spam calls or texts received increases dramatically every year. And that picks up trend right after the pandemic, right? So because everybody stayed at home and you pick up your phone, you are vulnerable to some extent. And if you can see the estimated cost or monetary loss to spam or scams, it has reached a new high right after 2 years after the pandemic. So almost $40 billion were lost to scams or telephone scams because of people who are vulnerable to that. So actually here in Lexington, in the Bluegrass region, I have received those kind of news almost maybe every quarter or so. So the news you see here is actually one from Richmond I believe this year, and one from Lexington last year. So it's all about somebody is spoofing police officers and use a caller ID from a police department to call you, please come to my department for reporting or do something really serious for yourself. But actually, they turned out to be fake robocalls or started with a scam calls. But this just gives you some idea that the situation is really kind of kind of a series everywhere in the United States. So the second risk I want to talk about today is actually is relevant to robocall, but it's not quite targeting scams or spams. So it's actually what goes before the scam and spams. So how does a scammer or spammers got your data in the first place? So the second risk is actually how does the MNOs or the carriers track you in the first place? So whenever you say you show your your password, your phone number, your social security to Verizon, to T-Mobile, Sprint, you are placing your trust on those mobile carriers, right? But it turned out they are not doing that fidelity to yourself. So they were selling your data to third-party data brokers for profits because they thought, why not? So according to these journalists, basically he paid a bounty hunter $300, and the bounty hunter just retrieved the location of their phone, and that becomes a serious privacy problem. So as you can see, in the year 2022, all the four big players, Verizon, Sprint, T-Mobile, and AT&T, they were fined for almost like $200 million for selling the data to third-party data brokers. And if we cannot stop that, I mean, that will certainly lead to more scams and spams because they will know your location, which will help them promote illegal telemarketing schemes. So, and as for mobile tracking, the term actually was researched for a very long time. So we are targeting the mobile network operators like the carriers, and they have the incentive to sell your data or to commercialize your data to third parties. And if they can sell your location data to third party like aggregators, they can be purchased again by then their customers, and which may not be that trustworthy customers. They will use that for unwanted ads, telemarketing, and even robocall scams. So as you can see, robocalls are the end results of those scams and your leaked numbers. And in the supply chain of those data items, MNO has been playing a major role in giving that data away for malicious attackers. So if you have worked for the US military or kind of a national security community, this is actually also relevant to them as well. What about the third data brokers? They are controlled by foreign agents, or they are kind of a threat to national security. This becomes a huge problem considering that the military operators, they may also have to use commercial networks for their like civilian communications or normal communications. So, but in all cases, as you can see, mobile tracking and the robocall scams, they are like two different aspects of mobile user privacy concerns in the 5G or even 6G era. So in the next sector, I want to briefly introduce how robocall scam works, the technical behind it, and why we cannot fix that with our current architecture, and also our own scheme, which was proposed last year. So how does robocall work? So basically, robocalls is not caused by the normal landline phones. You cannot do that. So you have to use something known as the VoIP client or voice over IP client. You are using a VoIP client to automate the generation of the robocalls, and you are auto-dialing the robocall to your customer. So basically, if you are not familiar with VoIP, you must be familiar with like Skype, right? So Skype is using exactly VoIP to making phone calls to real numbers. And robocall VoIP clients are just, scaling up to the spams and millions of, thousands of millions of customers at one time. And what is more problematic is robocalls or the VoIP clients, they might not be originated from the United States, maybe from overseas. So this is something out of our jurisdiction. We cannot do anything about that. And for the spoofed robocalls, one important technique is like a must-have for the attacker, which is known as the caller ID spoofing or faking. So there may be some situations in your phone, if you have a dual phone sets in your phone, one is landline, one is your pickup handsets. In some cases, you may observe they are showing different numbers. So the base set may show the correct unverified phone number, you don't know whom, but on the handset, you will see like a verified number from the caller. So basically, the one on your handset, the number was spoofed. So because the landline telephones like the PSTN and the cellular like the mobile phones, they may have different standards of verifying the caller IDs. But in any way, the root cause is the robocall client. They have all the means to change the caller ID to somebody else which you may trust. So as you can see, if you are familiar with this kind of victim experience, I believe almost everybody receives scam calls every day or every week at least. So very often that you will see the caller ID field has some phone number and you spoofed some legitimate government agencies like businesses like IRS, Washington, D.C. So although you are told that IRS will never call you, but what if something bad happened? I know I'm doing something wrong. I didn't submit enough tax. So if you have something bad, some bang at your end, you may be nervous about this kind of text message or phone calls. But anyway, if you look at the VoIP protocol, one of the constituent protocol is known as the SIP, Session Initiation Protocol. So whenever you want to use a VoIP phone, you are starting with the SIP protocol. And as you can see, the SIP protocol's very first message, invite, it contains a field known as caller ID. So this caller ID is not actually your phone number, it's the URI, Universal Identifier. So you can actually modify this field to somebody you think is important to the client. And the client, once the client, like a phone number operator, they can automatically translate this caller ID to this real phone number and whoever is recorded on their profile, and user will trust it. So this is exactly how the caller ID spoofing is done. You just change the field in this caller ID and the SIP message will go through. So to address this problem, the US government have been using actually every possible means to convince the MNOs to change their behavior to a more secure setting. So one of the most important policy improvements, which I think has been quite useful, is known as the stir and shaken protocol suite. So basically, stir stands for the secure telephone identity revisited, and shaken stands for signature-based handling of asserted information using tokens. But you don't have to know the details of how they work. So basically, stir provides a kind of authentication requirements. For every phone provider, you have to verify your customer. If you don't do that, you are not following the rules. And the caller ID authentication and verification are one vital step for how it works. So if you look at the figure, stir and shaken requires that whenever you are providing a service to a client, you are legally required to authenticate your client. I mean, at least in the United States. So whenever the callee's operator receives this phone call, and I can just double check the signature attached to this phone call with the verification service, and I will check with the operator's public key from the certificate repository, and if everything verifies, I will guarantee my customer that, okay, this phone call is trustworthy. But in reality, this paradigm faces so many challenges. The first thing is, what if this originator, they are overseas? They are not under the US jurisdiction. How do you guarantee that? The second is, for the smaller providers, like even the virtual MNOs, they may not have the means to always authenticate clients. So what if the clients, they just, I don't know them, I don't have time to authenticate them for the time being. So all those different practical issues is bothering stir and shaken in the practical use cases. And because of this, the gateway is actually, level stands for the originator is actually from a foreign providers. So but anyway, stir and shaken, they at least provide a way to promote legitimate businesses and help reduce spam and scam calls at some extent. So very often you can see from your phone app, whenever you have a check mark besides the phone number, which means it has been verified. But what is ironic is you can observe from this figure, which I use a screenshot from myself yesterday, you have a potential spam, and also you have a check mark. So this is actually quite interesting. Maybe iPhone is providing this potential spam check for you, but this check mark is actually from my provider, which is a Spectrum. So, and another thing very interesting is if you look at this number ending with 6365, and this one ending with 6366, it happened like almost 1 month apart. So this number is not verified, but this number is verified. So it seems that I am being targeted, and they have a mean to switch numbers into check-marked state. So it seems that stir and shaken does not provide the level of authentication which I expect, which you can see Apple provides this kind of a potential scam on behalf of me. But the true actually cause is actually originated from how stir and shaken works, because you are relying on a chain of trust. What if the originating provider doesn't provide doesn't do the due process of code authentication? So what if it is also like a compromised and it does not verify users at all? So stir and shaken really requires everybody on the chain to work properly before you can fully trust in your phone number from the coders. So at the other hand of the research from the academia, people are proposing like using apps, end-to-end code blocker apps, which I think has been very popular in these mobile application stores. So what you do is, I'm just using the internet to help you and the coder authenticate each other. And some of the apps, they are not using internet. They are purely using the voice channels. So what you do is, they will embed some kind of a noise-like messages in your voices, the acoustic channels transmitted in the signal level, and that part will fulfill TLS-like authentication protocol. But the problem is that the low bandwidth of the voice channels makes it very small, maybe 9 seconds. And some other schemes, they are using like a mutual authentication for between the caller and callee, but they have to assume internet connection at the time of call initiation. So that is actually not quite useful as well. So why should I have an internet connection when I'm using a phone call to verify the caller, right? So I believe those schemes, they are quite innovative in terms of connecting authentication with voice sessions, but they are not quite useful from a practical standpoint. So because of this reason, in last year, our team, we proposed a scheme known as the UC blocker. So UC blocker is quite radical in terms that you are not blocking callers, you are approving callers. So imagine if you are using Facebook or X, those social media apps, you have to ask somebody to become your friend first before they can make a phone call or voice message to you. So what we do is we are enabling a whitelist mechanism for your trusted callers, and at the same time, we are relaxing the limits for legitimate unknown callers or even trusted robocalls, such as from the medical campus, from hospitals, even from the police stations, schools. So we are using something known as the attribute-based caller authentication to realize this whitelist mechanism to make it scalable. So what we do is we are binding caller authentication to call initiation sessions, but we don't have to require an online authentication session. So basically, you can do this authentication session beforehand, and whenever it's up for you for the caller to make the call, you can attach the code to the session. So let me quickly explain how it works in a very brief style. So you conduct an internet-based or any kind of out-of-loop authentication between you are the callee with your caller. The caller uses something known as the anonymous credential. So the credential is actually called the caller credential, which encodes some of the key attributes, policies like the zip codes or some levels of trust. And whenever you have finished the authentication will provide something like this. several digits verification code. It's just like the passcode whenever you receive from the short messages to log in your web portal. And you fit into this verification code in the call session, the voice channels. And this is actually our whole design. So let me explain why it is so effective to provide privacy and also provide practicality. So before discussing that, I want to be a little bit more technical on the things that we use. We are using one cryptographic scheme known as anonymous credentials. So anonymous credentials is just like a normal certificate, but it's much more flexible and it allows you to selectively disclose your attributes to your verifier. So let me show how it works. So say you have a user, which in our case is a trusted caller you trust. The issuer is maybe somebody you trust, your MNO, or even yourself, the callee. I assign a credential to my trusted caller, a user, and the credential shows everything I put in on the attributes. So the credential is actually has all the attributes from the trusted authorities. And when the caller makes the phone call to our verifier, it can selectively show the only required attributes like a zip code. So for example, if I am the callee, I'm saying only those people within the zip code can call me. The caller can just conceal all the attributes except the zip code. And to do that, the caller has to also randomize the signature to make it like unlinkable to the original signature to provide privacy to the caller as well. And at the same time, we have to use one specific type of crypto scheme known as the zero-knowledge proof to show the validity of this presentation and of the knowledge of the original credentials. So this is a little bit tricky. Zero-knowledge proof basically shows that I know the original credential, but I don't want to show the original credential. I prove the knowledge of the original credential and the fact the presentation is directly derived from it. So that's the power of zero-knowledge proof. Okay, let's stop at this point. But the property nice to have is this presentation is selectively disclosing attributes and also is unlinkable to the previous credential, which gives privacy guarantees to the caller as well. All right, let's go back to our scheme. So first, the issuer, which will do that on behalf of the caller, I issue an original credential to Alice, right? And Alice has a full credential, which will be loaded into her phone app or UC blocker app. So I look up Bob's policy entry on the public bulletin board, which I called verifiable data registry. So basically, Bob's policy is public available on this data registry, which it says only those who are in the zip code area can call me, right? This is a very relaxed policy already for the caller you trust. And Alice just to show a one-time presentation of the original credential and conceal everything except for the zip codes and attach zero-knowledge proof to show the validity and authenticity of the presentation. So what is next is actually when Bob verifies this presentation, this is a success of the authentication, and the verifier will use the authentication to derive a very short 32-bit verification code, just like the kind of a one-time pad you use in your Duo app. So this app very code is derived back to Alice in the same channel in this one, and every step up to now they are known as out-of-band authentication for the trusted caller. And then Alice will deliver this very code along with her call request, and Bob will know that, okay, it is indeed Alice who has passed my out-of-band authentication, and I will start phone calls. So this is actually quite intuitive. Consider that everybody has used one-time pad before, right? Using a Duo app, use like a two-factor authentication. You have to have a second party providing a verification code before you can successfully log in your portal. So how do we actually realize that is actually more interesting from an engineering perspective? So normally to deliver this verification code, you have to have a second app like a Duo to help you enter those numbers, right? But in our case, we just reuse it's called ID field. to enter into this verification code. So if you imagine that, why we have robocall in the first place is because the caller ID is randomly set to fake IDs. I mean, in our case, we are mandating that caller ID is your verification code derived from your previous authentication session. So as long as the callee receives this SIP message and verify that, okay, this is a verification code which connects to our previous authentication session, this caller or this caller of the SIP session will be trusted as Alice. And because the size of the caller ID is only 32-bit, it's very short, it doesn't increase the overhead of verification whenever Bob receives this SIP message. So as you can see, we have implemented kind of a simulated UI on Linux with Android phone app. So we can, from a callee perspective, you can choose whatever like an attribute. So you are requiring the caller from a zip code, something like this. So if you are trusting Bob, you can share the following attributes with Bob for authentication zip codes. So basically, you are telling Bob that my policy includes the zip code. You have to get a valid credential for your zip code before you can call me. And there are many other attributes like the identifier, name, address, city, state, zip codes, and even date of birth. So you can specify the attribute you would like to have for a caller to be trusted. So this is how we are realizing that this whitelist style code blocking system. We are not actually approving phone numbers number by number. We're actually approving callers attribute by attribute because every attribute covers a whole bunch of different phone numbers, right? So we're trying to make whitelist mechanism as usable as possible. And we tested the scheme, I mean, particularly those cryptographic computations. It turns out that whenever you have a very small amount of attributes, the cost is kind of relatable, usable. But the problem is when you have more attributes, the cost goes to very high. But in reality, we may not want to use so many attributes for a trusted caller. Maybe your country codes, your zip codes, and even at most your age, right? So as long as we can make it practical and we can reduce the total length of end-to-end delay to 1.5 seconds. If you recall from a previous discussion, the two relevant schemes, one is on a scale of 9 seconds, and one is on a scale of also 1.4 seconds. But we don't require this kind of caller authentication to be done at the same time with the voice calls. You can do that offline, and as long as you can generate a verified code to the call sessions. So as a summary, UC Blocker provides flexibility to callee policy. So you can relax your whitelist attributes to make it more applicable to normal unknown callers, and is compatible with your existing SIP protocol, the VoIP, and also it provides privacy to callers. They don't have to disclose unnecessary information except for the zip code you want. And then the efficiency is we don't add any delays to the original protocol flow because we are just reusing this verified code, this caller ID field, to repurposing that as a verified code. So because the out-of-band authentication can be done with offline at an earlier time, it does not add to the delay. You have to wait for a call to come through, at least from a callee's perspective. So that concludes our discussion on the first problem on robocalls. But in practice, what is the cause of robocalls? We may have different theories behind it. Maybe you are disclosing your robocall, your phone number to third-party trackers, or in our case, the MNO themselves may disclose the phone number, your location, to your untrusted callers. So in this kind of a research direction, we are addressing this exactly MNO problem for the preamble phase of a robocall or scam calls. So before that, I want to give you a little bit of background on what is exactly a cellular network. So you may be using 5G or even 4G, 3G from very early in 2010s. So in the very simple case, our cellular network consists of two parts. One is the radio access. Basically, your phone is being connected to the phone tower or cell tower, like the Verizon base station for 5G. And in the back end, the cell tower or the 5G base station will relay your message, your information to MNO mobile core. This mobile core is actually sitting in the cloud, maybe in Verizon's headquarters, doesn't matter. And then this mobile core will include all those important functions to route your message to telephone networks or route your internet message to IP networks for the internet. So basically, this is everything we have to consider from an MNO perspective. They have to have radio access provided and also the cellular access provided with the mobile core. But the question is, how do MNOs track us, right? So like the examples I showed like several slides ago in the very first introduction, the MNO ended up selling our data to third-party data brokers. But how was the data collected in the first place? So this is actually built in this default mechanism for MNO to authenticate us whenever we are accessing their service. If you look at this simple example, you have a SIM card, right? A SIM card contains your important subscription information. One is SUPI. So SUPI stands for Subscription Permanent Identifier. And it has a better known name, which is known as the IMSI. If you are familiar with 4G standards, IMSI is exactly SUPI in 5G standards. So whenever you are connecting to your service provider, you have to go through an authentication and key agreement protocol. So in 5G, that is known as 5G AKA, authentication and key agreement. So within this protocol, you have to release your SUPI to your client, to your service provider. And because SUPI is globally unique, they can just create a database mapping SUPI to your phone number. So basically, after the end of the authentication, whoever serves you, no matter you are roaming or you are not roaming, you have to supply your SUPI and then your number to your service provider. At the end of the day, they will give you a globally unique temporary identifier for you to use the network on a day-to-day basis. So this SCUTI and SUPI, they together can help the MNO identify you uniquely on their network. So as you can see, this is like a built-in standard for 5G. We have no way to change that. So they have the default capability to track your identifier and your cell ID, because this cell phone tower has a cell ID which gives you a proximity of your location. So SUPI is associated with phone number, which will, if this data is sold to a third party, they can track you just by your phone number, know where you are by cell ID. But what is the consequence of that? So obviously, the MNO may sell this information to third parties, right? Because they are considered as the assets of interest to attackers. But what is more secure is, currently in 5G systems, MNOs, whenever you are connecting to several cell towers, physically they have the way to use like a geometry to exactly locate you. So using something like the trilateration, millimeter wave, they can locate you within the scale of 1 meter or 2 meters. So basically, you will basically share your coordinates to your historic coordinates to your phone company, and they may sell this information to third parties, which is a really serious concern if you are commuting to your workplace or school on a daily basis. You are almost using the same routes, and then the attacker will know that at this point of time you are at this position, and this is your school. They can just sit there and target you with robocall or scams. So this can be quite malicious, considering that the attackers can be telemarketers and even rogue policemen, police officers. So those are something we want to avoid. So, but luckily, before our work, we have seen some kind of a development, either from the improving the 5G network perspective, or from a new system perspective. So if you look at those academic work, zip phone and PGPP, well, they do have something in common. I don't want to share the identifier with the MNO who served me. So this is a core idea of our work as well. For example, in zip phone, so the user should actively update its identifier. I'm not always using the same subscription identifier or SUPI for a continuous operation of my life cycle of the SIM card. And for PGPP, it basically notifies the use of SUPI. Don't ever use SUPI at all. Don't use subscription ID at all. You can only access my network using internet access. So I'll give you, so the service provider, which is known as the PGPP service provider, will assign you an IP address basically to talk to the outside world. So as you can see, those two methods are kind of, so the second one is more radical. It just don't use any identifier. So you have to rely on internet for phone calls, for voices, which I think is not quite practical. The Verizon, AT&T, and all those likes, they still want to provide you voice calls on their native channel, right? You don't want to basically just drop everything you have on the voice calls and switch everything to IP internet service-based services. So in response, we propose a new mechanism known as AAKA. So AAKA stands for Anonymous Authentication and Key Agreement. So basically, it's AKA, but with anonymity for the users. So it's private against honest but curious MNO. So we still have to assume MNO will provide a service to us, right? Because otherwise, why do we use them? But we do assume that they are curious, they are privacy pegging, they want to know our information, our location. So it's known as the semi-honest or honest but curious. So we want to achieve anonymity. Users should access the network without revealing the permanent ID. I don't want to show my subscription to you, but I still want to use your service, right? It sounds like a little bit tricky, but it's doable. The second is unlinkability. Whenever I use my anonymous presence to use your service multiple times, you should not regard them as a single person. You cannot link multiple sessions to me as a single person because that will again constitute a security or privacy threat. And lastly, which I believe is very important, is what if I, as an anonymous user, I did something bad, I sold illegal drugs, and I committed crimes under my phone numbers. I mean, the police officer, they should still have the means to lawfully de-anonymize me just in case they need. So basically, it's anonymity, unlinkability, and accountability. So accountability is really, we are complying with the law enforcement's requirements. You have to allow them to do that whenever it concerns public safety. So the important feature is actually, again, anonymous credentials. So I introduced anonymous credentials in UC Blocker because they are used for the caller credential. And in our case, we are exactly using the same idea. It's not only caller, it's everybody. They have to use an anonymous credential to replace your original subscription credentials. So here is a concept. So whenever you are making payments to your home network, say Verizon, so along with the subscription identities or SUPI or its public key, you also have a credential derived from the home network. So the credential will also be stored in your SIM card and used for local storage. And whenever you want to access a service network, it can be the same Verizon network or can be a roaming partner. What you do is you are producing a presentation from the credential, and the presentation itself will authenticate you to the server. The server network doesn't have to contact home network to verify you. So this is a key powerful stuff over there. What if as long as the SN has to contact the home network, I mean, you lose your privacy, right? They can just collude to find out what you are. But our design is the SN, they don't know which exact credential you are using to produce this credential, and basically they cannot collude with the home network. So let me quickly go through the kind of a mathematical process. It's not quite important, but just to show you how we are designing the process as a cryptographic engineer. So normally, we come up with a goal. So the credential is actually very simple. 4 attributes, starting with your your status 0 or 1, right? It's like a binary choice. And then the time of expiration. If your credential will expire by this day, it will just expire. And the home network ID is the home network's identifier. So whoever is Verizon giving you that credential, M3 is Verizon's ID. But the most important thing is M4 is your unique identifier. And in our case, we just use SUPI because SUPI is a current uniform identifier you have to use in 5G systems. So the credential looks like the attributes and a bunch of signatures. So the signature is actually produced by the home network. It has to be signed by home network's own private keys along with the messages or attributes you want to have in the credential. So for now, you can ignore all the mathematical details, but at the end of the day, this credential as a software block, the block will be delivered securely into your SIM by the home network. So I believe whenever you are purchasing a new phone nowadays, you have the option of eSIM, right? So whenever you have an eSIM, you don't have to actually purchase a SIM card. Maybe Apple or Samsung will do that for you. They will connect you to the service provider. Service provider will do something known as over-the-air provisioning process to provision this credential to a SIM card or the kind of your existing subscription IDs to a SIM card. And then what you do is, again, very similar. By following the workflow of anonymous credential, you are generating a presentation of your original credential by hiding unnecessary content, right? So in the example, you are again only showing the zip code, but in our case, we are only hiding your identifier. We want to show that we are eligible, our subscription is active, and is not expired, and the home network ID, which is a Verizon, I want to tell my service network that this is all valid. The only thing I don't want to show you is my real identifier, the globally unique identifier SUPI. So to do this, we just attach 2 more fields to that. The first thing is you have to randomize your signatures so that the signature doesn't look like your original signature, so different presentations cannot be linked to the same people like me. And secondly, you have to prove that your identifier can be decrypted later by law enforcement officers. So to do that, we are attaching something known as the identity escrow. So identity escrow is another encryption mechanism known as algamo. You are encrypting your legal identity with some kind of a public key of your law enforcement. So what I'm saying is, this part, whenever the law enforcement, they are interested, they can supply their private key and decrypt your identity. But in normal operations, if you behave faithfully and do not commit crimes, I mean, you are good. You don't have to involve law enforcement to help you decrypt this M4 on behalf of your service provider, right? So this is just for the public safety reasons. We have to enable this identity escrow for later identity decrypting services. Yes. So yeah, I will introduce PI4 very shortly. So in this slide, PI4 is a zero-knowledge proof, showing the validity of your randomized signature and the validity of your identity escrow. So basically, let me quickly go to this slide. Pi is a zero-knowledge proof, proving that everything in this presentation has been computed correctly. So because as you recall that zero-knowledge proof is a statement showing that I know something I have, and I don't want to tell you what exactly that is. So, for example, I want to tell you that I'm over 21 years old to buy alcohol. I don't want to tell you my exact age. So this is like one concept for zero-knowledge proof, but in crypto terms, we're using a very specific type of zero-knowledge proof known as the signature proof. We are proving that this randomized signature is indeed generated through, from the original signatures, and also that this identity escrow is indeed generated from your original public key of your law enforcement. So this entire process may involve very complex mathematics, but it can be, if you are interested, we can go through them. It can be very interesting and rewarding as well. Because zero-knowledge proof is really like the new emerging technology from the last 20 years, which has been which like a new direction to those public key encryption schemes. So those are kind of a nice new tool for us to use for like a cybersecurity engineers. But anyway, if we are saying that this presentation is verified, I mean by verifying this pi, and then the SN will produce a random GUI for the anonymous users. So as you recall that GUI is your public identifier, which will be shown to everybody, so they can call you by this GUI. So by the end of the day, we want to summarize the property of this presentation where anonymous credential-based user authentication scheme is that the SN can verify the validity of the original credential without even knowing your SUPI, without even knowing your identifier, which gives anonymity, right? Because they only know you are a Verizon customer, you are a United States, we are within this country, and your credential is still valid. And at the same time, the accountability with ID escrow allows the law enforcement to decrypt you whenever you are committed some crime, and they can help the MNO to find out who you are. So these, I believe, are also very, very important, considering that many criminals, they're using 5G network for like a telemarketing or even scam calls. I want to locate them by allowing the law enforcement to locate them by de-anonymize them as well. So to give you some incentives on why we want to have accountability, so there's one emerging application of law enforcement known as geofencing. So geofencing has been quite kind of controversial in the past year because it sometimes leads to police brutality and also rogue policing as well. But at least from our standpoint, we are enabling geofencing only if you have a warrant, only if you have the private key corresponding to this public key. So we are enforcing that every law enforcement, you will have a verified public key in order to participate in this process. Otherwise, you are considered as a rogue police officer. But anyway, we are enabling geofencing. Basically, you are de-anonymizing everybody within your cell tower range. So if you are only interested in just one person, you can also you can target de-anonymize that person with a GUI as well. So basically, this is like two modes of de-anonymization. I think they can be very useful in a real case. As for our prototype, again, so we haven't sold this. We're marketing this kind of a new invention to anybody else, to the MNOs. We are just testing by ourselves with the prototypes. And we find that AKA introduces approximately 50% overhead of computation comparing to the normal 5G AKA verification. So it's not much, 60 milliseconds, but we were testing that in the ideal scenario with a simulated SIM card and a simulated phone app. And the line connects to a simulated 5G core as well. So we're comparing that to the normal 5G AKA. But what is really powerful of our design is in the roaming case. So if you look back on our design, whenever you are presenting your credential to a service provider, you really don't care if you are roaming or not, right? Because the roaming partner, they can verify your presentation without contacting your home network. So basically, we are blurring the lines between home network and service network. As long as you are accepting credentials, I mean, you are fine to claim the payments from us. So at the end of the day, we are using the two different methods, mobile tracking to address MNO's privacy risks, and we are using UC blocker to addressing the robocall scams, which is end-to-end user privacy risk. To give you a brief summary, both UC blocker and AKA, they use anonymous credentials, and I believe anonymous credential is very useful for crypto engineers nowadays. And UC blocker realizes a wireless approach to addressing robocall scams, and AKA using actually allows a mobile user to access a mobile network anonymously. So basically, AKA provides extra accountability features which allows the law enforcement to find you if we have committed some crimes or so. But for both cases, for the AKA case, it requires MNO cooperation because we are basically proposing a new company, a new MVNO service. I hope that we can find a partner to commercializing that, but for now we are still doing academic research. But if UC blocker is a pure end-to-end approach, you don't have to ask any change from the MNO. It's an end-to-end app for user applications. So now, lastly, I give you some open questions which we are still exploring. It's not solved yet. So the problem can be very subtle. In UC blocker, can we skip the trusted caller credential requirements for public services like schools or hospitals? I mean, it's very hard to convince them to use credentials, not calling you directly, right? So it's like a usability feature. The second thing is, in AKA, how are you gonna call anonymous user? I mean, they are browsing, they are accessing the network, excuse me, anonymously, and how does a trusted caller know where exactly I am? Where is my cell tower location? So this is like an open question we are trying to solve. And it's very likely that we can combine UC blocker into AKA, which can solve the problem. But then how do we enforce user charging, user billing as well? So all those things are practical challenges we have to solve before we are formally proposing this scheme to MNOs for their applications. And lastly, as you can see, what we have been doing is the scientific problem is how do we balance privacy, accountability, and usability. So all the three, they are all like almost like a trilemma we want to solve. So we can either use crypto methods, mathematics, or we can use like a practical methods like a voice calls, like the SIP channel. We are replacing the caller ID field. But I raise you as an open question. If you are interested, and you can talk to me offline as well. So that's the end of my talk. Thank you very much for being here. All right, any questions?
Well, we have about 5, maybe 6 minutes for questions. Any questions? I like this talk. I don't know if you like it.
Yes?
The anonymous credential,
Yes.
is it subject to a replay attack? If someone is able to intercept that credential, is it possible then for that man in the middle to reuse it?
Yes, that's exactly possible. So whenever you are using credential, you are not presenting the credential in the original form. You are presenting a presentation. So within that presentation, you can add a counter mechanism to stop replaying. Or for the receiver perspective, I can just remember all the presentation signatures. And whenever you have a dual presence of a presentation, you can just ignore that as a replay. So I think the normal practice of anti-replay, like counters, like those all things can still be used in the presentations. But I think the question is, what if the more severe question is, what if the credential is stolen, is copied by somebody else? I think we cannot solve that. We just assume that the SIM card is trustworthy, is in place, and whenever you stole the SIM card, you lose your money, you lose your credential subscription, something like that. Yeah.
We have a question here.
Yes.
So for the UC blocker, you said that it's based on attributes. Who and their verified attributes, who's doing like the verification? Like I noticed in your example, you have in California DMV.
Yes.
So would it be like a third party provides it to a central database, and in that third party, basically, they vouch that you have verified these attributes?
Yeah, I think that's a very good question. So the credential is actually issued by say the DMV, by the government authorities, or any kind of public trust entities. But the verifier is actually controlled by the callee themselves. The callee may have a cloud proxy for them, and the proxy will verify this presentation on behalf of the callee. So yes, the callee has to trust the cloud service to verify this presentation. Yeah, we are not fully decentralized. I like your question. It's really interesting.
Other questions?
So you're allowing the receiver to specify what credentials they would like to evaluate to accept the call. Likewise, are you going to allow the caller to specify what they're willing to put up to verify their identities? For example, if I don't want to share my zip code, can I make that specification? And then how do you resolve those conflicts when the requirements that are being provided and asked for don't match?
Yes, I think that's a really nice practical question. So in our current design, we are treating Alice, the callee, as the authoritative descriptor of the credentials. So the caller has to fetch the policy statement of Alice from the public ledger, public database. But I think is it possible the caller can negotiate a term with the callee beforehand. So say I am your close friend. I don't have to show that anything to you. So if the callee can publish different policy terms, policy statements to different callers. So you are more trustworthy, you can use that policy, and you are less trustworthy, you can use this general policy. I think that's one way to make it flexible. But I think what you mentioned is really important. It is possible to give the authority back to the caller, so that the callee can just accept what you can only know the attributes, cannot control the attributes. I think that's a different direction for this approach.
For the UC blocker sort of whitelist system, it seems like it works really well for people who you know or maybe expect you might get a call from them. I'm wondering about the situation in which we have, let's say I'm a site manager of like a manufacturing facility or something. I'm getting calls from multiple people across the US, maybe across the world a day. And what kind of information do you think would you be able to put something in there where like maybe an organizational sort of piece of information to specify people, or maybe if they're outside of the organization, some sort of like secret key or something to filter people by?
Yes, I think you are almost in the same direction as UC Blocker, its original design. So basically, all the organization, they can share like a public key. The public key is known to everybody, so it attests to the organization's credentials. So which requires that every callee put those attributes in their policy statements. So, but the problem is more practical. You have to ask every callee to put that attributes for that public key in your credential for you to do that. So I think this can be doable as long as you have like a government authority requiring you have to accept that call. So I think in the extreme case, whenever you receive an emergency phone call, you don't even have to have a SIM card. So it's like automatically happened. In the extreme cases, I mean, they can bypass the subscription as well. But in general case, you have to, in UC Blocker, you have to build the attributes in everybody's credential, in everybody's policy to make it happen. Yeah, that's actually the same question. Kind can we skip the quality credential for public services or organizations? I mean, we are trying to do that. Thank you.
Yes.
We don't have time because we need to eat pizza. So please don't forget to sign in. And we also have very interesting talk on AI next time. So come back again to join a very interesting topic 2 weeks from today. Again, don't forget to sign in. All right. Okay.